Hi, today we're going to be going over the repeating decimals and through the Pythagorean theorem quiz. This is your reteaching video, and so hopefully you can understand what you got wrong on your quiz. Here is number 1, and so it asks about how to, pretty much the process of taking a repeating decimal and putting it into a fraction. And so remember that we're going to subtract the behind minus the front. So this is how we get those two equations, and then eventually you're going to get x alone. That's the format. That's what we've been following. Pretty much we're just doing the equations itself. So first of all, as you can see, I wrote down a repeating decimal. So it is 8 is being repeated over and over and over again. And so that's why I have 8 with a bar. So it's going to be x equals 0.8. And I want to make an equation where the decimal is behind the first repeating part. So if we look at it, we want to go ahead and have that decimal go ahead and be behind the first 8 itself. So we're going to take this decimal and we're going to move it kind of once. So what we're going to do is we're going to go ahead and take the whole entire equation and we're going to multiply it by 10. So we have 10x equals 8.8 repeating. So this is the behind equation. Next, we want to go ahead and make an equation that is where the decimal is in front of the repeating part. Well, here, if we look at it, we already have where it is in front. And so the equation is just going to look how it is itself. So let's go ahead and let's put these two equations together. How does it look? Well, the two equations that we have is 10x minus 8.8 repeated. And then we're going to have it as minus 8x equals 0.8 being repeated. So which one of these is our answer that we want to go ahead and click on? As far as our final answer, it is this bottom one. Here is number 2. So it's going to be like number 1, where we want to go ahead and have we're subtracting, we're looking for the behind equation, and also the front equation is what we're looking for. So again, I went ahead and I wrote down pretty much what we have. Notice that the 531 is being repeated. That's why I wrote it as 531 with a line over it. And the first part, we want to go ahead and make so that the equation is that the decimal's behind everything that's being repeated. So see how it's going to sit behind the 531. And so there's 1, 2, 3. We're going to go ahead and multiply this whole equation by 1,000. And we end up getting 1,000x equals 4,531 point, and then 531 being repeated. Next, we want to go ahead and find where it is in front. So notice how the decimal right now is already in front of what is being repeated. So our equation, our second equation is x equals 4.531 repeated. Put those together. These are the two equations that we are looking for as far as going ahead and taking the repeating decimal and putting it into a fraction form. So which one are we going to go ahead and click on? It will be this one. Number 3, what we're going to do is we're going to use the same process that we used on question number 1 and 2, and we're actually going to find that actual fraction form. So as you can see, I went ahead and I wrote down x equals 0.32. The first equation we want it where the decimal is behind, so I see how it needs to be there. So I'm going to go ahead and it's 1, 2. So I'm going to multiply this whole equation by 100. And I'm going to get 100x equals 32.2 being repeated. And then the second equation is where the decimal needs to be in front of what is repeating. That's going to be here. So that's kind of like moving it once. And we're going to go ahead and take that whole equation and we're going to multiply it by 10 and get 10x equals 3.2 repeated. And kind of like what we did on question number 1 and number 2, we're going to go ahead and put those together as 100x equals 32.2 repeated minus 10x equals 3.2 repeated. And what we're going to do is we're going to go ahead and subtract those and subtract downward. So if we subtract 100x, we get 90x. Subtract off the 32.2. The repeating part cancel each other out. So it's really 32 minus 3, and then we get 29. And then we're going to take this green equation and we're going to solve it. We're going to go ahead and get the x alone. So how do we do that? 90 and x are multiplying. We're going to go ahead and divide both sides. And we're going to go ahead and get, so here's our dividing. And then we're going to get x equals 29 over 90. So the numerator, again, is the top part of our equation. So that's 29. Bottom is 90. Here is number 4. Again, we're going to do number 4 kind of like number 3. We want to make those two equations that we've been making. And so we're going to go ahead and write down x equals 11.2 repeated. Make a behind. So take the decimal, move it over to behind. We're moving it once. So we're going to take this equation, multiply it by 10. We're going to get 10x equals 112.2 repeated. And then we're going to make an equation where it is in front of the stuff. So in front is here. So did it actually move? It did not. So our second equation is just the x equals 11.2. We're going to put those together so we can go ahead and subtract them. So we have 10x equals 112.2 minus, and then remember that this x is 1x. How many x's are there? There's 1. So it's pretty much 10 minus 1. We get 9. And then the repeatings all cancel each other out. So it's 112 minus 11. So 112 minus 11 is 101. And then we go ahead and we divide by 9 on both sides. And then we have x equals 101 over 9. So the numerator is 101. Denominator is 9. Number 5, again, we're doing the same thing. We're making the two equations that we want to go ahead and where the decimal is in front. And then a front of the repeating part, also behind the beginning part. We're going to do the behind first. So notice how the decimal that is behind, it's here. So it's 1, 2, 3. We're going to take this equation and we're going to multiply it by 1,000. So we get 1,000, x equals 586.586 being repeated. The the front equation is here. Well, okay, it's already there, so we're still going to use the same equation that we have. And again, like we did before, we're going to do the behind minus the front. And then remember that x is considered just as 1x. And so we're going to have 1,000 minus 1x is 999. And then we have the repeating part. Again, they all kind of cancel each other out because we're subtracting, makes it 0. And it's 586 minus 0. Okay, well, that's 586. We're going to go ahead and divide by 999 to get x alone. And then we have 586 over 999. So numerator is 586. Denominator is 999. Number 6 is the 3D Pythagorean theorem part. So remember, when we did the Pythagorean theorem, it is our length squared plus our width squared plus our height squared added together and then square rooted. So let's go ahead and let's put in our information that we have. So we have 3 squared plus 4 squared plus 12 squared. And let's go ahead and square those, add them all together. What do we get? We get 169. We want to take the square root of that. So stick it in your calculator. You should get something like this. Oh, well, we don't have to round. We don't have to worry about that. Our answer is 13. Number 7, again, length squared plus width squared plus height squared. Let's put that into our equation. So we're going to have the 12 squared plus 5 squared plus 4 squared square rooted. Add all of those together. We get the square root of 185. Stick it in your calculator. And we get this big number here. And it says that we want to round it to the nearest tenth. Tenths is the 6th part. So we're going to look at the 0. Is 0 5 or above? No. So we're going to leave it exactly how it is. So we're going to have it as 13.6. Again, on number 8, we're trying to find that diagonal of the cube, the box. So length squared plus width squared plus height squared. Put those numbers in. We're going to have 9.6 squared plus 2.8 squared plus 7.5 squared. Add them together, and we get 156.25. And then we are square rooting that. Stick that in your calculator. We are going to get just 12.5. We do want to round it to the nearest tenth. So our tenth is here. And so the 12.5 would be our final answer. Number 9, it says find the length of the longest rod that you can place inside a box. If you really think about it, again, it's that diagonal that we're looking at. So again, it's the length squared plus width squared plus height squared. Put those in. So we have 13 squared plus 16 squared plus 17 squared. Add them together. We get square root of 714. Put that in your calculator. We get something like this. So again, we want to have it, this time it says round it to the nearest hundredths. Well, how many decimal places is that? That is 2. So we're going to have, we want that 2 position. We're going to look at the 0. Is that 5 or above? No. So we're going to leave it exactly how it is. So then our answer is 26.7. Number 10 is like number 9. Again, if you really think about it, trying to put the longest rod inside a box, it is that diagonal. So we have that length squared plus width squared plus height squared. Put those numbers in. So we're going to have 8 squared plus 1 squared plus 5 squared. Add those together is 90. We're taking the square root of 90. Stick it in your calculator. We have something like this. So we want this time it says hundredths place. That is 2 decimals. And we're going to look at the guy next to him. Is that 5 or above? Yes. Give the original a shot. And then our final answer should be 9.49. So hopefully you understand what you did wrong on your quiz, and you're able to go ahead and take the retake and do much better. Have a good day. Thanks.